So we were discussing the type of centers. Before that, we discuss colleagues. So what is colleague? What is four-jaw colleague? And the colleagues will look like this: the Mayan 47. Yeah. So now centers basically they are of two types. One is live center and another is dead center. So centers can be light duty centers and heavy duty centers. So heavy duty centers they have bearings supporting heavy workpieces. Of course, between center. Then you have a multi-duty center. So it has a taper roller bearing. This is your taper roller bearing at one end. So it's because of the bearings, it carries the load. So this is your between center location. This is your between centers. So this is only location. Then you have mandrel, which is used for round pieces or round bore, hollow bore. So this is a mandrel. This is called the expanding mandrel. It on this, it slits. It can take the or it can accommodate the various type of bores, like say 20 to. So because of these slits, it can expand. So that's why it is called as the expanding mandrel. This is how the mandrel sleeves will look. This is your mandrel sleeves. So your workpiece is located on the outer diameter. And as I said, that mandrel is used for locating the hollow bore. So the symbol will be shown like this. So this is a symbol uh, for location and clamping. For guiding the tools. Jigs can hold the tool. At the same time, it guides the tool. Generally, the jigs are drilling jigs, but the fixture. Picture for car, frame look like modular fixture means fixtures which are made in parts. So this is a modular. Then you need to the body. Then once that is done, then all the components of the fixture. The fixture planning means
Sir,
it deals.
sir, sir, your voice is
Yes,
breaking, sir. It's lag, lag is.
this is the overall design specification. The fixture layout is nothing but conceptual drawing of the fixture. Then once you have conceptual drawing, then you have to design picture body. That is what should be the size as depending upon the weight of the workpiece. Then picture elemental design, that is components design, that is individual components. the side worked out. So this is what. So if I want to summarize, workpiece control is divided into three parts. That is, like suppose if it is asked distinguish between geometric control dimension. So workpiece control is divided into three parts. It's geometric control dimension control. So first difference is in terms of geometric control as that which relates to the stability of the workpiece. So workpiece should be stable. So workpiece should not lift, workpiece should not rock away. So that is what is seen in geometric control. And in dimensional control, it refers to the maintenance, that is maintaining the physical dimensions. Then mechanical control means like you have to apply the forces, clamping forces properly. Mechanical control is.
Sir, your voice is breaking.
So other differences. Sorry,
Your voice is breaking, sir.
hello. Voice is breaking, but everything is settings are correct.
So maybe connection.
Now is it maybe connectivity का issue है. Uh, so what are the advantages of good geometric control? So operator skills and efforts are not required. Your fixture design in such a way that your workpiece will automatically come to rest to the reference. So you don't have to take any efforts to look at the workpiece or to take the references of the workpiece. The holding forces will have less tendency to shift the workpiece away from locators. Hmm? So geometric control में the holding forces will not shift the workpiece. If there are any surface irregularities, that is, if the surface is not flat, it will cause less variation in workpiece position, provided locators are placed at wider distance. The tool forces it has less tendency to shift the workpiece away from the locator. Means it will not shift despite of any cutting tool forces. As the locators are placed at a wider distance, if there is a even if there is a slight wear of the locators, it will not have much effect positioning. How do you get a good geometric control? Distribute locators a broader base. Dimensional control that you can obtain the dimensions within the given tolerances. Even if there is workpiece variations, you still get proper dimensions within tolerances if we have proper dimension control. There will not be any process tolerance tag. Process tolerance tag I will explain when we study tolerances. How to get good dimensional control? You do good dimension control. You have to select the correct surfaces for keeping the locators. That is, from wherever the dimensions are given, that surface, that reference surface has to be selected. Then once you select that, what are the advantages of mechanical control? The workpiece will not, because of the tool forces or because of the holding forces, mechanical control will give you, you know, workpiece is forced to contact all locators when you are applying the clamping force. Workpiece will not get distorted. Your component will not shift away. How to obtain good mechanical control? It is obtained by correctly positioning the holding forces. You do the supports properly, and you have to position the locators also properly.
Sir,
Yeah,
sir, in jigs, which control we use? Geometric, dimensional, or mechanical?
all the three controls in G. You get correct
Sir,
dimensions. So you have dimension control. Then you get a job stability also. So you have geometric control and you have also. So mechanical control also. Actually, whatever clamping etc. what you are doing, you should get our aim is process. The aim of the process engineer is not to get a particular control. The aim of the process engineer is to get all the controls. You should get all the controls, geometric, dimension, and mechanical.
okay, sir.
Hmm. Now in workpiece control, this equilibrium theory is important. So so there are two types of equilibrium. One is linear equilibrium, and another is rotational equilibrium. And the purpose of all this control, that is your geometric control, dimension control, and mechanical control, is to get both the equilibrium. That is linear equilibrium as well as rotational equilibrium. So what is linear equilibrium? Like
Sigma
suppose
affects zero on
this is
acceleration.
a yeah, yeah, net force should be zero. And what is rotational equilibrium? That is moment
Sir,
should be
moment
zero.
at any point should be zero.
Yeah. So so the purpose of the control is to equilibrium. Then I just wanted to state this alternate location theory. That is any excess of locator may cause loss of workpiece control. May, not necessary that it will. But in certain cases, excess of locators are desirable. And these excess locators are referred as alternate locators. So these axis locators are referred to as alternate locators, and the purpose is to improve the center line control. Then it is necessary for mechanical control when holding forces cannot be used. And less operator skill will be required, obviously. And alternate locators can ease the tool design and reduce the cost of the workpiece holder. One of the duty of process engineer is machine selection. So of course, the first is your, there are two factors. One is cost factors and another is n factor. And in cost, process engineer has to consider two costs, that is investment cost and operating cost. And third is intangible cost. Investment cost is obviously means the investment in the machine. So that includes your initial cost of the machine is accessories. Accessories means cost of the tools. Then many times, you need chucks, hardware chucks, software chucks, sometimes stabilizer, voltage stabilizer, AC unit. So all that chiller unit, all that comes under the accessories. Installation cost will include your civil cost, that is making the foundations, then transportation cost, that is moving the machine from manufacturer to the end user, and tool cost. Tool cost means your cutting tools, jigs, fixtures, etc. etc. Operating cost will include your labor cost, your material cost, sometimes indirect labor. Indirect labor means cost of the supervisor, cost of the managers, GMs, chairmen. These are indirect labor. Direct labor means who is working on the machine and producing that component. That is direct labor. Maintenance cost, repairs cost, rework cost, then of course electricity. So intangible cost is nothing but downtime cost. That is your breakdown cost. Your breakdown may be achieved due to machine failure, operator carelessness, negligence, accidents. Hmm. So that will cost, isn't it? That is your intangible cost. Then other than cost factors, you have another, that is design factor. So in design factor, like what accuracy and surface finish is given in the drawing, what is the productivity required. So accordingly, you have to select the machine. Process engineer has to select the machine. Like suppose if you want the accuracy of 1 micron, or if you want the accuracy of half micron, 0.0005 on the component, then accordingly you have to select the machine. So half a micron means you have to go for more machines. That is six machines. That's the only one machine which will give you half microns accuracy. Then again surface finish. What kind of surface finish is required? So accordingly you have to select the machine. Then productivity. Like suppose if you want quantity, more quantity in mass productions, okay, then you have to go for SPMs, special purpose machines, or you have to go for single spindle automats, or you have to go for multi spindle automats. So depending upon the quantity, your machine's selection of the machine will vary. Again, if the quantity required is more, then as I said that you can go for single spindle automat, multi spindle automat, SPMs. You can go for Shoblin lathes. So your accuracy, surface finish, and productivity will definitely affect the machine selection. And the process engineer should have knowledge of all this, machine tool manufacturer. That is, which machine gives what accuracy, which machine gives grinding finish, or which machine gives lapping finish, which machine is suitable for mass production. So process engineer should be aware of all. Then what I wanted to tell you here, we have been using the word toolings, and this is for the short note. So toolings is described as the device or devices which is used to adopt the standard or special machine to a given workpiece. and you should invest in tooling also as a process engineer, because if you have a very good machine of say 1 crore or say 3 crores, but if you don't have proper tooling, then the machine will not be utilized. There will not be any utilization of the machine.
Sir, yeah.
Yeah,
Sir, tooling is different from machine tool, right? तो मशीन टूल
yeah,
मतलब
tooling
वो
is
जो
different from
कटिंग करे मतलब ऐसा और टूलिंग मतलब
machine.
सर क्या फिक्स एंड फिक्चर
हाँ, मशीन टूल मतलब जो लेथ मशीन है, ड्रिलिंग मशीन है, शेपिंग मशीन है, that is your machine tool. Tooling means your cutting tools, drill बोलो, reamer बोलो, your jigs, fixtures,
सर सर
V blocks,
कटिंग टूल्स
parallel
नहीं
blocks.
सर
Cutting
सिर्फ
tools भी
टूलिंग
tooling में आ जाता है.
अच्छा
No, no, cutting tools also comes under toolings.
सर टूलिंग्स
मेरे
मतलब
पास
ऐसा
भी
कर सकते हैं क्या एक्सेसरीज फॉर ऑपरेशन और मशीन टूल करके ऐसे बोल सकते हैं ना
yeah, yes, yes, yeah. Many times we say कि
एक्सेसरीज या फिर वर्क
machine
होल्डिंग
मेरा
डिवाइसेस
yeah, work holding devices, even cutting devices also. Many times we say कि 20 lakh का मशीन है और मेरे को टूलिंग में I had to invest 5 lakhs. Many times people say like that. Hmm. I have invested 5 lakhs in the toolings. So means he has invested in tool holders, workpiece holders, jigs, fixtures, cutting tools, etc.
सर
So
जैसे लेथ
if you're
मशीन में भी
investing,
एक
yeah,
जनरल पर्पस सर लेथ मशीन में जैसे
क्या
जनरल पर्पस मशीन था और एक स्पेशल पर्पस लेथ भी होता है सर टरेट वगैरह तो सर टूलिंग्स में भी होता होगा ना
STMs,
कि स्पेशल पर्पस टूलिंग्स भी होते हैं जो जनरली यूज कर सकते हैं अलग अलग मतलब सेम शेप के पर डिफरेंट साइजेस के लिए या फिर मतलब कस्टमाइजेबल भी होते हैं सर ऐसे उनको अपग्रेड भी किया जा सकता है
yeah, customize, yeah, customized toolings also. Huh? Tailor-made tools, form tools. Like once I had shown you the brooch, 600 millimeter high. Sometimes if you have a complex shapes on the workpiece, then you have to form the tools. So that is a customized tool.
और सर जनरल टूलिंग्स भी
So
होते हैं क्या सर
general tooling, matlab, this is what now we are discussing. So tooling can be commercial, regular, and special. So commercial means ये जो purchased, हाँ, vendor catalogs, मतलब which are available. Like आप market में गए, so 10 का deal, 12 का deal, so these are available as a standard sizes. So that is your commercial toolings, which can be purchased directly from every vendor. He has his brochure, so you have to just refer to the code, and that code has to be mentioned in your purchase order. So commercial toolings is standard sizes. So what is the advantage of using commercial or purchase tooling? See, as a product engineer, you should design your product in such a way that it can be produced with the help of commercial toolings or standard toolings. Otherwise, it is going to become a costly affair. So if you are going for commercial or purchase tooling, then your cost is low. Then you get a good quality because the suppliers they are mastering that toolings. Like suppose if I take a drill, so drill बोलेगा तो Indian tools, IoT that is very famous for the drills, famous. If I say vernier caliper, so meet it to you. If I talk about carbide inserts, CNC car, then sandwich or is car. So the cost is low because the suppliers they are specialized in their fields and therefore you get a higher quality. Then commercial tooling will reduce or eliminate the design time. Since the cost is low, you can maintain the inventory because if the cost is high, like the brooch which I had shown, the cost of that brooch is 10 lakhs. So nobody will keep that brooch as an inventory. Nobody. So what are the types of the toolings? So it includes your tools. Tools means your cutting tools. And this is tool holders. This is tool holder. That is for holding the insert. You need to have a holder. Then workpiece holders. That is clamps, strap clamps, mold patterns, dies, templates, gauges. These are all nothing but the tooling. You have expandable tools also. That is expandable mandrel. If you want to classify tools, then it can be classified as cutting tools, forming tools, and assembly tools. So cutting tools will include your drill, reamer, tap, and mill. Forming tools means will include punch, dies, assembly tools for assembly. Like welding is used for joining. Rivets are used for joining. Nut and bolts are used for joining. So holders can be chucks. That is, you can hold a tool in a chuck. For example, imagine a lathe machine. So you can suppose if I want to do the drilling, then I can hold the drill in the chuck and I can keep the component on the tool post or on the tailstock and do the drilling. Then the tools can be held in collets, can be held in sleeves, can be held in tool bit holders. Then adapters and arbors. Arbors are generally used on milling machines. Then you have workpiece holders. So workpiece holders are your jigs, fixtures, V block, vice, mandels, collets, chucks, and all this you are familiar. You know even sleeves. What is sleeves? Sleeves are used for holding the drills. Adapter is nothing but a spindle adapter, which has a taper. Bundles are used for holding the hollow component. Then gauges can be fixed gauges and comparator. Fixed gauges means plug gauge. Plug gauge is used for measuring internal diameter. Ring is used for measuring outside. Snap is used for outside. Inline, flush pin. Flush pins, inlines, they are used for measuring the depths. Filler gauge, filler, F-E-E-L-E-R. Filler gauge is used for measuring the gap. If there is a gap between two parts, so how much is that gap? A small gap, which cannot be measured by your vernier or micrometer. So in that case, filler gauges are used. Comparators, again, it can be gauges. So mechanical, air, electrical, electronic, and optical. Mechanical comparators means your dial indicators. So you're keeping your dial indicators on the workpiece and measuring out of roundness. How much is the out of roundness? So this was your workpiece control and toolings. So we have finished with the module 1 and module 2. Module 1 is introduction to process engineering, product engineering. Module 2 is your preliminary part analysis and workpiece control. So now we'll go with the tolerance chart. Before we go for the tolerance chart, you should know hmm, why the tolerances are required. Hmm. And before you study the tolerance chart, you have to also take the make or buy decision, like whether to make in your factory or whether to not make in your factory. It is not not to be made means that you will outsource, that is you will buy. That is what is called make or buy decision. All right, so we can stop here and then we can continue with tolerance chart in the next class.
Hello.
Sir,
Yeah,
Sir, what is the portion for UT1?
UT1 the portion is process engineering, then preliminary part pin analysis, and workpiece control. So there will be 2 marks ke 5 questions
Okay, sir.
out of question number one. You have to solve 5 questions out of 8 questions, and then question number three you have to solve questions. Question number that is having 5 marks out of 4. So it's a 20 marks test. So question number two will be subjective. I mean descriptive. Question number two will be short answer type.
Okay, sir. Sir, are you going to provide question bank?
Yeah, I'll provide.
Okay, sir. Thank you, sir.
Yeah, most welcome.